Hi, everyone. Welcome. I have Bob and Brad with me here today, and we are so excited to be launching our Wiretap desktop app. It's available for Windows, Mac, and Linux. So we're so excited to launch this app. It is the first in our industry. It is a Modbus discovery tool designed specifically for renewable energy sites.
Christina, thanks for that lead in. One of the questions we get from our customers as we have previewed and shown them Wiretap is where the name comes from. Because, of course, everybody thinks of wiretapping as being something illegal. So there's nothing illegal going on here. There's no phone lines involved or FBI. Wiretap has the unique ability to listen to an existing Modbus serial chain and discover the device IDs and also the registers that are being communicated between, say, like weather sensors and an existing data logger. And it's not limited to just weather sensors. Anything that talks on a serial chain via Modbus RTU can be listened in on and essentially reverse engineered. And that's where the name Wiretap comes from. We have used this tool internally for the past few years in our Acuity product when we're doing retrofits on legacy sites. So there is perhaps an existing data logger or a PLC or an RTAC, and it's communicating with all these devices, but there is a lack of information about how those devices are addressed. The configuration for that data logger may not be available to the client. And so in wanting to upgrade their sites, instead of having to reverse engineer, everything or track down documentation, Wiretap has allowed us to put our computer on site and essentially listen to the communications that are already there. And using that information, we can map those device communications into our system. And so this has really been a huge utility for us. And what we wanted to do is we wanted to open this up to the technicians in the field, the commissioning agents, and of course, people who are looking to switch over to our product. And this removes the need to actually have to buy our data logger, our Acuity product first. You can download Wiretap for free. You can install it on any laptop that you own. And Christina, like you said, this runs on Mac, Windows, or Linux. So anybody can use this. And you don't really need to know a whole lot about Modbus to make it work. You literally just plug it in and then listen for the devices and tags that are currently on the serial chain.
So Brad, I have a question. So when you're talking about you need a connected device, so we need to connect it locally or we can do it remotely as well?
Yeah, that's a good point, Bob. So for those of you not familiar with how Modbus works, there are both networked connections, which is called Modbus TCP communication, and that's where devices send the serial communication over a network. And potentially, if you had remote access, you could listen for that information remotely. The real use case, though, that a lot of customers find themselves in is their devices are using Modbus RTU. Some people call this RS485, which is just the wiring name. But that information is not available over the network and it cannot be accessed remotely. So this does require someone to go into the field and actually connect to the serial transmit and receive wires. And we have a couple photos to show kind of the common scenarios that people might run into and just how easy this is to do. We can take a look at a couple examples of kind of how this looks in the field. This jumble of wires, for those of you who don't know, is pretty typical to what we run into in the field. And what we have here is we have a protocol converter, which is what this atom is, and it's taking sensor information, so maybe for a weather station, wind speed, temperature, backup module, and all those inputs are coming in on the top of the atom. So these blue and green and red and black wires. On the bottom, these are the actual Modbus signals, then the Modbus RTU. And each one of those sensors has an ID, which we don't know. And there are registers, data being pulled from those sensors that we also don't know at the moment, but they are being sent through those little wires on the bottom. So what Wiretap allows us to do is literally tap the transmit and receive wires on the bottom of this atom, and then in running the program, listen for what device IDs are being communicated with, which sensors, and what values are being pulled back in the form of registers. And we can do all that without having to break the current connection and without having to really know anything about how those devices or how the Modbus chain is currently set up. If we look at the next slide, this is also a fairly common situation. So on the left-hand side of the screen, we have a picture of a communications board inside a string inverter. And the string inverters are set up to act as pass-through devices, meaning that the inverter prior to them brings its Modbus in. So those are the blue, orange, and green wires on the left-hand side of that board. And then the current inverter's information, plus any previous inverters, leave on the serial chain to the right. So the blue, orange, and green wires on the right then go to yet the next inverter. This is called a serial chain. So you have multiple devices connected using these pass-through comms boards. And each inverter has its own device ID, but you also have registers being pulled for all those devices. At the end of the chain, those serial wires, that blue, orange, and green, finally end up in some type of a control cabinet. And in this case, they're landed on some terminal blocks, and they ultimately go to a data logger that is already communicating with those inverters. So in this case, the blue and orange wires are the transmit and receive for all of the communication for those inverters. And we can simply tap into those, again, without breaking the communication between the data logger and the inverters, and we can listen and we can discover all the device IDs for the inverters and all the registers that are currently being pulled. So then if we look at the next one, this is a slightly different situation we run into. So here we have a controls cabinet and we have a meter, a shark meter in this case, and that shark meter is a serial RS-45 communicating device. And so what they've done here is they've installed a protocol converter where the meter is talking serial to the bottom of that atom in this case, and then the atom actually exposes the information to a network. And then that network looks like it's heading up to a switch that is mounted on the upper right-hand corner of the box, a network switch. And then ultimately, it is going into this Novata data logger. So in this case, we actually don't have to listen to the serial chain. We could simply join the network. And so if there was an open network port on that switch, we could simply plug into it. And instead of listening, we could actually scan this network in order to find not only the atom, which is the network connected device, but any other device either in this cabinet or connected to the network that is currently communicating Modbus. And then we can also scan each of those IP addresses for Modbus registers. So in this case, we could actually not just scan the meter, we could find anything that is connected to that network. All right. And then finally, this is another example of a weather station. So we have serial or RS-45 connected devices coming into the bottom of the box. That's what those black whips are. And those are coming up to a set of terminal blocks. And then it looks like there is a small PLC that is reading in communication from those. And that PLC is IP addressed, it's on the network. And so we actually have two options here. One, we could plug into the switch and we could scan the network, which would not only give us that PLC, but anything else in the plant that's connected to the network. Or if we were only interested in the weather station sensors, we could simply tap the two wires. It looks like they are maybe white and yellow coming into the top of that PLC that are connected to all the sensors below. So Wiretap allows us a really surgical methodology for being able to come and either do whole plant-wide communication discovery of devices and registers, or we can do something very surgical where we can just look at a particular part of the plant that is communicating on serial chains, which are notoriously difficult to reverse engineer and find information on.
Thanks for watching part 1 of our introduction to Wiretap. Don't forget to watch part 2 and to download Wiretap today.